And then I think,
Okay, let me just edit out until
yeah,
I
we'll
start.
chat at the very beginning.
Okay. Just background sound. Okay. Good afternoon. My name is Avery Blaylock, and this is our project on AI and Spotify, an introduction to AI, analyzing the AI value chain in company use cases. It's letting me, oh, I had to tap the thing.
Yeah, for
Okay, let me
sure.
restart.
Yeah,
Wait, what? Now it's okay. Now
yeah,
it's doing
it
it.
was
Okay,
weird.
you can use the arrows now. I cleared it away. Let me go back. We-
Just like sitting here going,
I was kind of looking at it.
I did this like 5 times to calm down. Okay. Good afternoon. My name is Avery Blaylock. This is our project on AI and Spotify, Introduction to AI, Analyzing the AI Value Chain and Company Use Cases. So start off the breakdown of the AI value chain. We're going to be looking at the data collection, data pre-processing, data storage, model training, model evaluation, model development, and output generation. The types of data that we're collecting include age, gender, how long you've used Spotify, what type of device you listen to, like a phone, Amazon Alexa, or a computer, what type of Spotify subscription plan you have, if it's premium or basic, which preferred premium plan you have, preferred listening content, and favorite music genre. So how it's gathered includes tasking with monitoring the methods that the user does on the app, what tasks the user follows on the app or the website. It recommends songs similar to what you've already have in your listening history, and it takes notes of things such as the time of day the song was listened to, the genre of the song, the title, and the overall amount of time listened. For data pre-processing, processes over 500 billion events daily, collects direct user actions, plays, skips, likes, playlist ads, and indirect behaviors like listening, duration, and pattern. Analyzes audio files for musical qualities like tempo, key, and mood, cleans data by removing incomplete, duplicated, or inconsistent entries. It organizes data by tagging user actions and categorizing audio features, and uses feature engineering to create new variables for songs and preference.
Hi, I'm Jaden. I'll be talking about data storage. So for the data storage, Spotify used to house all their data on their own servers, but for scalability and innovation, they moved over to Google Cloud Platform, or GCP for short. GCP and Compute Engine are used for their large-scale storage and processing for all their data. They also use systems like Bigtable and Datastore for the vast amounts of data that's structured. They also use pub/sub streams for real-time user events, so they're tracking this in real time of user interactions with the platform. And they replace these older systems for faster analytics using BigQuery, Dataproc, and Dataflow. And once again, it supports billions of events daily, powering AI features like Discover, AI DJ, and Spotify Wrapped. As for model training, Spotify uses machine learning to make personalized recommendations for users, things like playlists, song recommendations, artists. For reinforcement learning, it allows the models to learn from user interactions, so skips, likes, the durations of their songs, lengths of playlists, things like that. They use collaborative filtering, which compares users with similar listening habits and suggested new music. So people that listen to the same types of playlists, same types of songs, music, artists, things like that, they'll categorize them all in one. And then natural language processing, it helps to interpret music-related text and personalized stories in Spotify Wrapped. And lastly, they use deep learning models, so neural networks to analyze musical elements within each song. For the model evaluation, they use shared models that learn from user interactions, which again is skips, likes, song durations, things of that nature. Collaborative filtering to group the users, They use song metadata, audio features, and cultural context used for enhanced recommendations for the platform. They use machine learning home, which tracks and compares model performance across different versions that engineers from Spotify create. They also use implicit user feedback, which is used to fine-tune the models, so the actual data from the users in real time. And then A/B testing used to evaluate the model effectiveness before they deploy it in a larger scale for everybody to use. And then lastly, for model deployment, the AI model is deployed through a robust machine learning platform that Spotify uses. It uses Salem, which is the model serving framework, which is built on TensorFlow, and ensures consistent workflows across the different machine learning applications within the software. And again, the machine learning home is used to manage the deployment and tracks the performance of the product readiness before it is deployed. For output generation, it builds user profiles based on age, gender, listening habits, and engagement. The AI DJ creates real-time curated playlists for people that have the same similar tastes. Discover Weekly, Daylist, and AI playlists offer personalized recommendations for content, songs, music, and artists. The Spotify Wrap delivers yearly visual summary of listening behavior. Podcast voice translation provides translated audio and original speaker's voice. And lastly, the personalized outputs are used across the smart search and on the home screen of the actual Spotify software.
My name's Aiden, and I'm going to be covering the intermediate AI components that Spotify uses to transition between stages in the value chain. Uh, Specifically, these four listed right here. So first is between the data pre-processing and model training stage. They use feature extraction done with convolutional neural networks to convert the raw audio data into usable numeric format, like tempo, chord, pitch, length of song, anything else you could imagine like that. And recurrent neural networks and LSTM networks are used when time is important. For example, if there's a tempo shift halfway through the song. After this, natural language process is done alongside to understand user-generated text and learn like nuanced associations between descriptive text and music. So, for example, social media posts, playlist titles and descriptions, reviews. And so after that, feature selection and engineering is done to transform the data into an even more usable form. This prevents model overfitting, improves accuracy, and reduces training times for models. An example of that would be the feature skips per genre or skip rate per song. You can see that they combined the data from skipping it with other features to create a new one that's more descriptive. And then normalization and scaling just prepares the features for training by putting them on a consistent scale, preventing certain features from overriding other ones. For example, the decibel feature could override certain genre classifications if it's weighed too heavily, and they might think that all songs that are loud fall under one genre. So between the model training and model evaluation stages, validation and cross-validation systems are used for testing the trained models on unseen data. This estimates the generalization, catches overfitting, and ensures that new models don't just memorize the data. And it uses methods such as k-fold cross-validation, stratified sampling, and holdout sets. Between the model evaluation and model deployment stages, model selection and versioning is done to select the best model based off of accuracy, latency, interpretability, and they track the model lineage and ensure reproducibility and compliance with standards using tools like MLflow, SageMaker Model Registry. They do A/B testing frameworks or use multi-armed bandits to evaluate these models in live environments and get feedback. And so between model deployment and output generation, they use contextual decision systems to adjust the outputs on real-time contexts like location, device, time, and this enables a greater personalization of the recommendations. They use rule-based logic, contextual embeddings, and lightweight contextual neural networks to power these improved recommendations. Like, for example, Spotify's DJ and the daily mix can adapt to the time of the day and whether or not a user is commuting, and they're both large parts of Spotify's user experience.
Thank you. Now, moving on to measures of financial performance. of AI and Spotify, we'll be looking at total revenue growth, cost savings, ROI, market share, and customer satisfaction. So in the fourth quarter of 2024, which is the quarter where Wrapped comes out on Spotify, there was a mark of 12% increase in monthly active listeners, 11% increase in total subscribers, and a 16% increase in revenue, which equates to $4.79 billion. And looking at the transition from quarter four of 2019 to 2020, from a new method developed to handle the immense amount of Wrapped data needed, there was an estimated 50% decrease in data flow costs for Spotify.
So I'm Faith, and I'll be going over the financial performance. So because Spotify did not disclose the exact cost, we had to estimate that at about around 200,000. So the net profit was 157 million in quarter four. And so just to estimate how much of that was attributed to Spotify Wrapped, we estimated about 1%. And with the ROI formula, that leads us to 6,370%. So Spotify made 63 times their investment in implementing the AI. So for market share in the quarter four of 2024, Spotify reported 675 million users, and their new DJ feature added a competitiveness with Spotify Wrapped. So for comparison, in 2023, Apple Music had 93 million monthly listeners, and Spotify had 602 million listeners at the same time, showing a massive lead. And so moving on to customer satisfaction, Spotify Wrapped was first introduced in 2016. And before Wrapped in 2015, Spotify had 91 million active listeners. And after Spotify Wrapped was released, they had 160 active listeners per month. And paying customers also jumped from 28 million to 71 million. And this shows that 62% of the users that interacted with Wrapped spent more time on Spotify after Wrapped than before the campaign. On to Kate.
Okay, so for our AI model, my name's Kate, by the way. For our AI model, we first started by getting a data set from Kaggle called Spotify User Dataset. And we began by cleaning our data, checking for missing values, and assessing the quality in Excel. And then we tried a couple different types of models, like random forest and linear regression. But it ended up that the cat boost regression was the best fit because it automatically encoded all of our categorical variables. And it has built-in regularization techniques to prevent overfitting. And it's good for unbalanced data sets, which we figured out ours was. We ran our model using Python and following these steps, defining our target variable, encoding our categorical columns using Python, splitting our data into training and testing, trained our model in the training data set, then used our regressor to then create our model, and then we tested it with our testing, and finally predicted and evaluated using R-squared and RMSE and feature importance. So here's the variables we ended up keeping. Our data set was huge, so there was 20 variables, so we narrowed it down to the 9 that were most relevant because there's a lot of variables involving like podcasting like that didn't really have much to do with the AI recommendation. And we also figured out that all 10 of our variables are categorical, which makes making models a bit more challenging. So for our regression model results, we found that the most impactful variables include the music exploratory method, podcast listening frequency, and duration of Spotify usage. So for our RMSE, it was on average that our model was off by 0.9 points on our rating scale of 1 to 5 for our independent variable, which is a self-reported user opinion about AI or their Spotify AI recommendation models. And for our R-squared, we found that it explains around 6.4% of variance. And some limitations that decreased the strength of our model included the nonlinear relationship of our variables to our independent variable, which again was the recommendation self-reported scale. The data set is on the smaller side, and our target variables are subjective and self-reported. And we still think that our model is still useful to gain preliminary insights into how consumers feel about Spotify. And some potential improvements would be to collect more data and filter out for inconsistencies. So for our recommendation model, we created a mock Spotify recommendation chatbot using Python and basic natural language processing. The chatbot takes in user input and provides personalized music suggestions based on moods or genres. For genre-centered queries, we made it like a simple keyword-based model. So if the user says one of our keywords, we give them the matched genre with recommended songs, artists, and playlists. And for queries that don't include one of our trigger keywords, we implemented sentiment analysis using the Vader sentiment Python library that assigns a sentiment, whether that being positive, negative, or neutral to the query, and makes its recommendations accordingly so that no matter what the user inputs, they will have a recommendation. And here's just an example of our AI model and our chatbot. So you start by asking you what you're in the mood to listen to. And if you say, for example, for the first one, give me some throwback hits, that triggers the word throwback in our in the genre centered query. And then the stressful day and I'm a bad mood would trigger the sentiment analysis that you seem very negative and that you might want something chill like coffee house jazz. Or even if you say surprise me, I don't know what I'm in the mood for. It seems you sound positive because of the exclamation point. So it recommended party music. And the final one is just another example of the genre-centered query suggestion. And that's all. Thank you.
Yeah, and you just like
I don't know how to.